Okay, so we want to deal with rational expressions that have binomials in them, and we want to simplify them, reduce them, in other words, divide them. So in algebra, I have 4 plus x over x plus 4. And if I look at that, I see a binomial 2 terms divided by a binomial 2 terms. The biggest mistake you guys make is you want to separate the terms. If this is connected by addition, you cannot separate the terms. Okay? So what I always tell my students to do is put parentheses around them. They cannot be separated. I'm asking you to divide this whole entity 4 plus x divided by this whole entity x plus 4. And what I want you to notice is a relationship. What do you know about writing in algebra 4 plus x and x plus 4? Well, you notice the x's are exactly alike. They're both positive. The 4's are exactly alike. They're both positive. And according to the commutative property of algebra, we can rewrite the numerator as x plus 4 in the correct descending order, and the denominator would be x plus 4 in the correct descending order. And now we're dividing a binomial by itself, and we learn when we divide the same expression, our answer is always 1. Now, let me prove to you why this answer is 1 and not 2, because I know what you're all thinking. You're all thinking 4 divided by 4 is 1. X divided by x is 1. 1 plus 1 is 2. Well, that's not following order of operations. First thing to show you is to think about, let's replace x with a number. If I replaced x with 1, then this expression would have been 4 plus 1, which you would have told me was 5. And you would have said down here in the denominator, 1 plus 4 is also 5. And 5 divided by 5 is 1. So that's one way to prove to you why I know the answer is 1. The other way is to understand why you can't separate the terms. There's a big difference between writing a fraction connected by multiplication and connecting it by addition. So let's go back to 3rd grade. If I wrote 6 times 5 divided by 2, most of you would do what's in the numerator. You would do 6 times 5 is 30, and then you would do 30 divided by 2 and get 15, correct? Well, there's another way to work that expression. Because this is 6 times 5, that's multiplication, and the fraction bar means division, according to Please Excuse My Dear Aunt Sally, order of operations, it doesn't matter if you multiply first or divide first. They're equal. You can do them in either order. So if I looked at this expression and I divide it first, doesn't it make sense I could divide 2 into 6? And that would leave me with 3. And 3 times 5 still gives me 15. So when multiplication and division are connected in the same expression, you could do either operation in any order because they mean the same thing. If you look at this expression and I write 6 plus 5 divided by 2, from 3rd grade you would add 6 plus 5 first, get 11. You would divide 11 by 2, and that would give you $5.50, or 5 5/10. You all with me? Now, if you thought, oh, I'm going to divide first because I see the fraction bar, you would be wrong because look, this is addition. You can't do division if you're connected by addition. I'll show you it doesn't work. If I did division, I'd do 2 into 6 3 times, and 3 plus 5 is going to give me 8. It's not going to give me that $5.50. So it's important to understand when you can divide and when you cannot. If you're connected by multiplication, if you're monomials, yes, you can divide first. But now we do not have monomials, we have binomials. You cannot separate the pieces. You have to look at it as a whole entity. And a binomial divided by exactly the same binomial, the answer is always 1. For this binomial, I have 5 minus d divided by d minus 5. First thing, I can't just divide the 5's and then divide the d's. I can't separate them. So I'm going to put my terms in parentheses. Okay, so I know they're stuck together. Like a ball and chain, they're glued. I'm going to say, okay, let's look at these binomials. Do they mean the same? Are they the same binomial? Or are they additive inverses? Well, this 5 is positive. This 5 is negative. They're not the same. They're additive inverses. But to truly be an additive inverse, all the terms have to be opposite of each other. So let's check. This d in the numerator is negative. This d in the denominator is positive. So we truly have additive inverses here. Well, from arithmetic, we know if we divide additive inverses opposite, our answer should be -1. Now, I'm going to prove to you why. First thing is you can make a number up. If I, again, put for d, I put a 1 here. This would be 5 minus 1, which would be 4. This would be 1 minus 5, which is -4. What is 4 divided by -4? It is -1. If I rewritten the numerator in descending order, I'd have a negative d, the d is negative, and then I have a positive 5. The denominator is already in descending order. And if I look, negative d and positive d are opposites. 5 and -5 are opposites. The correct word for opposite is additive inverse. And when you divide additive inverses, your solution is always -1. And that's what you need to start realizing. You can't take it apart as separate pieces because it's a binomial, it's connected by addition, and you're not allowed. It doesn't follow order of operations. You have to divide it as a whole entity. Okay, let's work on that. I'll see you in the next video.